Unlocking nature's superconducting secrets, unearthing the secrets of naturally occurring superconductors. In a remarkable scientific discovery, researchers have stumbled upon a naturally occurring mineral that exhibits the remarkable properties of superconductivity. Hyun-Soo Kim and his team have unveiled the surprising revelation that the mineral meosite, also known as RH17S15, can conduct electricity without any energy loss, a hallmark of superconductors. The journey to this finding began in the laboratory, where the researchers synthesized the RH17S15 compound and observed its superconducting behavior below a critical temperature of 5.4 Kelvin. What makes this discovery truly intriguing is that the superconducting properties of meosite differ significantly from those typically seen in conventional superconductors. Conventional superconductors are known for their isotropic energy gaps, where the superconducting state emerges uniformly around the Fermi energy. However, the researchers found that in the case of meosite, the superconducting gap closes along certain symmetry directions, a characteristic of unconventional superconductivity. Further investigations using penetration depth measurements revealed another peculiarity. While the penetration depth, which determines the distance a weak magnetic field can penetrate the superconductor, is typically temperature independent at low temperatures, meosite exhibited a linear temperature dependence. This observation is a telltale sign of the material's unconventional superconducting behavior. Interestingly, the superconducting properties of meosite also displayed a strong dependence on the presence of non-magnetic defects, unlike conventional superconductors, where such defects have little to no effect. The discovery of naturally occurring superconductivity in meosite challenges the prevailing notion that unconventional superconductivity is solely a product of artificial synthesis. This finding opens up new avenues for exploring the fundamental mechanisms underlying this phenomenon and could reshape the focus of contemporary superconductivity research. One potential impact of this discovery is a shift towards more sustainable and environmentally friendly approaches to superconductor research. The researchers suggest that the scientific community could move away from the use of toxic elements, such as arsenic, selenium, and uranium, in favor of naturally abundant minerals like meosite for understanding the mechanisms of unconventional superconductors. The discovery of naturally superconducting meosite is a testament to the power of scientific exploration and the constant quest to uncover the hidden secrets of the natural world. As researchers delve deeper into the intriguing properties of this mineral, they may uncover new insights that could revolutionize our understanding of superconductivity and its applications in various fields, from healthcare to quantum computing. Source: www.nature.com. Rapid monkeypox virus detection using ultrasensitive single-step CRISPR test. Breakthrough monkeypox detection, a rapid, sensitive, and field-deployable CRISPR solution. In the ever-evolving landscape of global health challenges, the recent monkeypox outbreak has raised urgent concerns worldwide. Researchers have now developed a game-changing solution, a rapid, ultrasensitive, and field-deployable CRISPR-based diagnostic platform that can detect monkeypox virus, MPXV, in just 15 minutes. The revolutionary system, dubbed SCOPE, Streamlined CRISPR on Pod Evaluation Platform, represents a major stride forward in pathogen diagnostics. Leveraging the power of CRISPR technology, SCOPE can detect as little as 0.5 copies of MPXV per microliter, a truly remarkable feat. This single-step process eliminates the need for complex sample preparation, dramatically simplifying the workflow compared to conventional methods. The key innovation lies in SCOPE's seamless integration of recombinase polymerase amplification, RPA, CRISPR, Cas13a transcleavage, and an ingenious vest pocket analysis device. The device, aptly named CPod, handles the entire process, from rapid viral lysis to fluorescence signal acquisition and interpretation, without the need for any external equipment. Notably, SCOPE has demonstrated 100% sensitivity and specificity in validating 102 clinical samples, including 35 MPXV positive cases, outperforming the gold standard qPCR assay. This remarkable achievement underscores the platform's potential to revolutionize point-of-care testing, especially in resource-limited settings where access to sophisticated instruments is limited. The researchers have meticulously optimized every aspect of SCOPE, from the single-step RPA CRISPR, Cas13a assay to the streamlined viral lysis and reagent lyophilization. This harmonious integration of cutting-edge technologies has resulted in a truly user-friendly and field-deployable diagnostic solution. As the world grapples with the evolving threat of monkeypox, SCOPE emerges as a game-changer, poised to empower healthcare professionals and communities with rapid, sensitive, and accessible diagnostics. This innovative platform not only enhances our ability to detect MPXV but also holds the potential to be adapted for a wide range of other infectious pathogens, paving the way for a future where timely and accurate disease surveillance is the norm. Source: www.nature.com. Unveiling AlphaFold, a milestone 50 years in the making, unraveling the mysteries of protein folding, a scientific tale 50 years in the making. In the realm of molecular biology, the intricate dance of proteins folding into their optimal configurations has long captivated the scientific community. 50 years ago, researchers were just beginning to scratch the surface of this complex phenomenon, laying the groundwork for the remarkable advancements we witness today. The 1970s saw a pivotal shift in our understanding of protein folding. Observations revealed that under the right conditions, many proteins could spontaneously and reversibly fold into their biologically active forms. This groundbreaking discovery suggested that the linear sequence of amino acids contained all the necessary information to guide the folding process, sparking excitement about the potential of artificial synthesis and genetic engineering to create novel protein structures with unprecedented functions. However, the challenge lay in predicting which specific sequences would result in the desired conformations, and how long the folding process would take. As our scientific understanding deepened, it became clear that the final stages of folding were the most difficult to anticipate, requiring a delicate balance of computational power, advanced algorithms, and a vast repository of data. The path towards the remarkable achievements of AlphaFold, the revolutionary protein structure prediction tool, was paved by the gradual accumulation of knowledge and the tireless efforts of generations of researchers. While the ultimate goal of accurately predicting protein folding from sequence alone remains elusive, each step along the way has been a testament to the ingenuity and perseverance of the scientific community. Interestingly, the language used to describe these advancements has also evolved over time. The ambiguous use of the term axiom by Sir Isaac Newton, which sparked a historical debate, serves as a reminder that scientific terminology can sometimes be subject to interpretation and nuance. As our understanding of the fundamental principles governing protein folding continues to deepen, the precision and clarity of our scientific communication will be crucial in driving further progress. As we reflect on the remarkable journey of the past 5 decades, we can't help but be awestruck by the remarkable strides made in unraveling the mysteries of protein folding. The path forward, though still challenging, is now clearer than ever, with the promise of groundbreaking discoveries and transformative applications on the horizon. The future of molecular biology has never been more exciting. Source: www.nature.com. Exploring quantum sensing in the megabar range. Quantum sensing breakthrough unlocks secrets of high-pressure superconductors. In a groundbreaking development, a team of researchers has unveiled a revolutionary quantum sensing approach that is poised to transform our understanding of superconductivity at extreme pressures. Led by Prabhudya Bhattacharya and colleagues, this innovative study has shed new light on the elusive Meissner effect in hydride superconductors, a long-standing challenge in the quest for room temperature superconductivity. The pursuit of high-temperature superconductors has taken a fascinating turn in recent years, with a growing focus on materials subjected to immense pressures. Theoretical predictions have suggested that the strong electron-phonon coupling and high characteristic phonon frequencies in hydrogen-rich compounds could stabilize superconducting states at temperatures as high as 300 Kelvin under megabar conditions. However, probing the magnetic signatures of these superconducting phenomena has proven to be a daunting task for conventional experimental techniques. The sensitivity limitations of magnetic sensors at such extreme pressures have hindered the direct observation of the Meissner effect, a hallmark of superconductivity. Bhattacharya and colleagues have now overcome this challenge by harnessing the extraordinary sensitivity of nitrogen vacancy, NV, centers, defects in the diamond lattice that are exquisitely responsive to magnetic field variations. By carefully protecting the intrinsic symmetry of the NV structure, the team has demonstrated enhanced sensitivity and high-contrast magnetic field measurements, even in the face of the extreme pressures involved. Using this innovative quantum sensing approach, the researchers were able to directly monitor the local magnetic response in samples of a recently discovered cerium hydride superconductor at pressures up to 140 gigapascals, GPa. To their delight, they observed distinct local field expulsion signatures, clear evidence of the Meissner effect, and directly imaged the micron-scale inhomogeneities in the superconducting regions. Complementary resistance measurements confirmed the bulk superconducting transition, and further exploration of magnetic field and thermal cycling unveiled temperature-dependent hysteresis and flux-trapping behavior, reminiscent of a disordered superconductor. Interestingly, the team also observed differences from canonical expectations, such as a sharp transition for certain magnetic field amplitudes, hinting at the complexity of these high-pressure systems. This groundbreaking work establishes NV-based quantum sensing as a powerful tool in the megabar frontier, paving the way for the optimization of superhydride synthesis and the nano-imaging of magnetism, charge, and lattice dynamics at unprecedented pressures. As the scientific community continues to push the boundaries of our understanding of superconductivity, this study stands as a shining example of the transformative potential of quantum sensing technologies. Source: www.nature.com. Unlocking India's Potential, Building a Scientific Superpower, Unleashing India's Scientific Prowess, a Transformative Vision. As India's general election unfolds, the nation stands at a pivotal moment, poised to harness its immense potential and emerge as a true science powerhouse. The world's largest democracy, home to nearly 1 billion voters, is set to chart a course that could shape the future of global scientific advancement. India's impressive achievements in recent years have laid the groundwork for this ambitious transformation. From becoming the fourth country to achieve a soft moon landing to leading the world in affordable medicine production, the country has demonstrated its scientific acumen. However, the true catalyst for India's rise as a science superpower lies in its ability to bridge the funding gap and unlock the full potential of its research ecosystem. Recognizing this, the Indian government has taken a decisive step by establishing the Anusandhan National Research Foundation, ANRF, a funding agency tasked with dispersing a staggering 500 billion rupees, $6 billion, to universities and laboratories over the next 5 years. Crucially, 70% of this funding is expected to come from non-governmental sources, such as philanthropists and industry. This move signals a profound shift in the approach to science funding in India. Traditionally, the burden has fallen heavily on the public sector, with around 60% of research spending coming from the government and universities. In contrast, leading economies like the OECD nations and the European Union see a much greater contribution from the private sector, accounting for up to 74% and 66% of R&D spending, respectively. India's thriving corporate landscape, with global players in industries ranging from construction to information technology, presents an untapped goldmine of potential. These companies, recognizing the immense value that strategic investments in science can bring, must be encouraged to step up and become more generous patrons of research and development. The incoming government, regardless of political affiliation, must seize this opportunity to forge a new partnership between the public and private sectors. By incentivizing and facilitating greater corporate involvement in science funding, India can unleash a wave of innovation that will reverberate across the globe. Moreover, this collaborative approach must be accompanied by a renewed emphasis on fostering autonomy within the research system. Researchers have long lamented the neglect of basic research, and the ANRF must work tirelessly to shatter these perceptions and cultivate an environment where cutting-edge, curiosity-driven inquiry can thrive. As India stands on the cusp of a transformative era, the choices made in the coming years will echo through the decades. By strategically aligning public and private resources, the nation can harness the boundless potential of its scientific community and emerge as a global powerhouse, redefining the frontiers of human knowledge and innovation. Source: www.nature.com. Unlocking Insights from the 2023 Turkish General Election. First public dataset available. Captivating the pulse of Turkey's political landscape. A sweeping analysis of the #SESAM 2023 social media dataset. In the lead-up to Turkey's highly anticipated 2023 general elections, the role of social media in shaping public discourse has become increasingly pivotal. Recognizing the urgent need to understand these evolving dynamics, a team of researchers has assembled the most comprehensive dataset to date, the #SESAM 2023 dataset. This groundbreaking trove of information promises to unlock a wealth of insights into the intricate web of political narratives, strategies, and potential manipulation tactics unfolding online. Spanning a diverse array of data sources, the #SESAM 2023 dataset paints a multifaceted portrait of the Turkish political landscape. From tracking the ebb and flow of trending topics on Twitter to meticulously mapping the social networks of key political figures, this resource empowers researchers to delve deep into the intricacies of digital campaigning and electoral influence. One particularly striking finding emerges from the analysis of automated accounts, or social bots, and their potential impact on the online political discourse. The researchers uncover alarming patterns of coordinated behavior, with certain politicians' accounts exhibiting suspiciously high proportions of bot followers. This discovery underscores the pressing need to understand and mitigate the threat of digital manipulation, as the integrity of the electoral process hangs in the balance. Beyond the bot menace, the dataset also offers a window into the broader dynamics of political engagement on social media. Researchers can now trace the evolution of public sentiment, the diffusion of information across networks, and the interplay between traditional and digital media. Such insights could prove pivotal in informing strategies to foster more informed and inclusive political discourse. The true power of the #SESAM 2023 dataset, however, lies in its potential to inspire cross-disciplinary collaborations. By bringing together computational and social science experts, this resource paves the way for innovative research that bridges the divide between technology and the nuances of political behavior. The insights gleaned from this data could not only shed light on Turkey's elections, but also inform the global conversation on the role of social media in shaping democratic processes. As Turkey prepares to chart its political future, the #SESAM 2023 dataset stands as a testament to the power of data-driven research. This remarkable resource promises to empower scholars, policymakers, and the public alike, equipping them with the tools to navigate the complexities of the digital age and safeguard the integrity of the electoral process. The journey ahead may be fraught with challenges, but with the #SESAM 2023 dataset as a guiding light, the path to a more informed and transparent democracy has never been clearer. Source: DOI.org. Revolutionizing Agriculture, Nanofertilizers for Sustainable Greenhouse Gas Reduction, Revolutionizing Agriculture, How Nanofertilizers Are Tackling Climate Change and Boosting Food Security. In the face of a growing population, climate change, and the unsustainable practices of the Green Revolution, the agricultural industry is at a critical crossroads. However, a glimmer of hope has emerged in the form of a revolutionary technology, nanofertilizers. Researchers from the Connecticut Agricultural Experiment Station, the University of Minnesota, and Nature Sustainability have unveiled a groundbreaking discovery that could transform the future of agriculture. Their study, published in Nature Sustainability, reveals how nanoscale iron fertilizers, multivalentFe304 nanoparticles, can significantly reduce greenhouse gas emissions, enhance soil nutrient retention, and boost crop yields, all while addressing the pressing issue of food insecurity. The study's findings are nothing short of remarkable. By co-applying these nanofertilizers with urea, the researchers observed a 50 to 52% reduction in methane, CH4, and nitrous oxide, N2O, emissions, two of the most potent greenhouse gases. Remarkably, the nanofertilizers also increased nitrogen, N, uptake by the plants and retained more soil nitrogen, effectively mitigating the loss of this critical nutrient through processes like ammonia volatilization and nitrate leaching. But the benefits don't stop there. The nanofertilizers also had a profound impact on soil health, with a significant increase in soil organic carbon, C, levels. This carbon sequestration not only aids in climate change mitigation but also enhances the overall fertility and resilience of the soil. The cherry on top? The use of these nanofertilizers resulted in a staggering 55% increase in rice yield, a testament to their ability to optimize nutrient delivery and utilization by the plants. This is a critical finding, as rice is a staple crop for billions of people worldwide, and improving its productivity is essential for global food security. The researchers highlight that the combination of reduced greenhouse gas emissions, enhanced nutrient retention, and increased crop yields makes nanofertilizers a game-changing technology for sustainable agriculture. By tackling the intertwined challenges of climate change, environmental degradation, and food insecurity, these nanoscale innovations offer a glimmer of hope in an otherwise bleak landscape. However, the researchers acknowledge that there are still unanswered questions regarding the precise mechanisms by which these nanofertilizers exert their benefits. The fate and distribution of the iron within the plants, as well as the dose-response relationships, warrant further investigation. Nonetheless, The potential of nanofertilizers to transform the agricultural landscape is undeniable. As the world grapples with the daunting task of feeding a growing population while mitigating the devastating effects of climate change, the emergence of nanofertilizers stands as a beacon of hope. This revolutionary technology holds the promise of a more sustainable, resilient, and productive agricultural future, one that can nourish both the planet and its people. Source: www.nature.com. Evaluating the influence of climate litigation on promoting environmental action, a research study, uncovering the power of climate lawsuits, a journalist's perspective. In the ever-evolving battle against global warming, a new weapon has emerged: the courtroom. As climate litigation soars worldwide, researchers are delving deep into the impact of these legal actions, uncovering a surprising story of how lawsuits can catalyze tangible change. From the Netherlands to Germany, the ripple effects of landmark court decisions have sent shockwaves through governments, forcing them to strengthen their climate policies and curb corporate greenwashing. The Urgenda case in the Netherlands, for instance, compelled the government to not only meet its emissions reduction target but also invest billions in climate measures and accelerate the phase-out of coal-fired power. Similarly, in Germany, young environmental activists' legal victory led to a significant boost in the country's emissions reduction goals, pushing the timeline for climate neutrality forward by 5 years. These successes have been hailed as truly historic by researchers, who emphasize how science-backed arguments have empowered citizens to hold their leaders accountable. But the true impact of climate litigation extends beyond just the courtroom triumphs. Even cases that fail to secure immediate policy changes can still play a crucial role in raising public awareness and paving the way for future victories. The Juliana versus United States case, for example, may have faced numerous legal hurdles, but it has inspired a new generation of climate activists and influenced subsequent lawsuits, like the one won by young people in Montana. The power of climate litigation, however, extends beyond governments. Corporations are also feeling the heat, as researchers have found that lawsuits against major fossil fuel companies can lead to significant drops in their share prices and curb greenwashing practices. This financial and reputational damage sends a clear message to investors and companies alike, that ignoring the climate crisis comes at a steep cost. As the landscape of climate litigation evolves, experts foresee a surge in new and innovative legal strategies. From demanding compensation for climate-related loss and damage to challenging the over-reliance on unproven carbon capture technologies, the courts are becoming a battleground for the fight against global warming. Crucially, this shift extends beyond the global north, with more climate cases being filed in the global south, where the impacts of climate change are often more severe. The recent landmark ruling in India, affirming the fundamental right to be free from the negative effects of climate change, underscores the growing global momentum behind this legal movement. In the words of one researcher, litigation allows stakeholders who often don't get a seat at the table to be involved in pushing for further action. As the world grapples with the escalating climate crisis, these courtroom battles may prove to be the catalysts for the bold, science-based action that our planet so desperately needs. Source: www.nature.com. Uncovering valuable insights from previous mitigation strategies, unraveling the climate challenge, lessons from past mitigation efforts. As the world grapples with the escalating threat of climate change, a new study sheds light on the successes and challenges faced by countries in their efforts to mitigate this global crisis. Drawing insights from past climate agreements, the research provides a compelling narrative that underscores the critical importance of effective monitoring and review of national climate action plans. The study, published in Nature Climate Change, delves into the performance of 34 countries in achieving their emission reduction targets set at the 2009 Copenhagen Climate Summit, COP15. Surprisingly, the findings reveal that only 15 of these nations were able to meet their 2020 mitigation goals, while 19 struggled to reach their targets. The researchers, led by Shuping Li, carefully analyze the factors driving these divergent outcomes. They find that the dominant force behind emissions reductions across all three groups, successful, halfway, and failing, was the lowering of energy intensity. This was followed by improvements in industrial and energy structures, which played a crucial role in either reducing or offsetting the rise in emissions in some countries. However, the study uncovers a stark contrast between the successful and struggling nations. For the failing and halfway groups, the primary challenges were the growth in income per capita and population size, which outpaced their efforts to curb emissions. In contrast, the successful group managed to offset these growth-driven pressures through more substantial reductions in energy intensity and structural changes. These findings offer critical insights as the world transitions towards the ambitious goals set by the Paris Agreement, which aims to limit global temperature rise to well below 2 degrees Celsius above pre-industrial levels. The authors emphasize that many countries must intensify their emission reduction efforts compared to the previous decade to meet their 2030 targets. Failing to do so could jeopardize their ability to achieve even more demanding long-term objectives, including net zero emissions. The study's authors propose several strategies to address these challenges. One key recommendation is to enhance energy intensity reductions and carefully reassess national energy structures, ensuring that emissions reductions can be sustained even in the face of growth-driven pressures. Importantly, the researchers also highlight the need to account for the carbon leakage phenomenon, where emissions are outsourced to countries with less ambitious climate targets through international trade. They suggest the implementation of border taxation as a potential solution to this issue. The lessons learned from the COP15 mitigation targets underscore the complexity of the climate challenge and the importance of ongoing monitoring, evaluation, and target reassessment. As the world continues to grapple with this existential threat, this study serves as a sobering reminder that the path to a sustainable future requires a careful, evidence-based approach that addresses the unique circumstances and constraints faced by each nation. Source: www.nature.com. Understanding the effects of stopping obesity medications, unraveling the rebound, the complex reality of quitting obesity medications. In the ever-evolving landscape of healthcare, a new class of weight loss drugs has taken the world by storm. Medications like Wegovy and Ozempic, known as GLP-1 agonists, have become some of the most sought-after treatments for managing obesity. However, as the popularity of these drugs soars, a new challenge has emerged: what happens when people stop taking them? Contrary to the common belief that these drugs should be a lifelong solution, a surprising statistic has emerged: about 2/3 of those who started taking a GLP-1 agonist in the United States in 2021 had stopped using them within a year. The reasons behind this trend are as diverse as the individuals themselves. From the brutal side effects that some experience to the financial burden of maintaining the costly treatment, the factors forcing people off these medications are multifaceted. In the United Kingdom, the National Health Service, NHS, even imposes a 2-year limit on coverage for weight loss drugs, further complicating the situation. As researchers delve deeper into this phenomenon, a clear picture emerges. When the GLP-1 agonists are taken away, the body's natural weight regulation mechanisms kick back into gear, often leading to a substantial regain of the lost pounds. In one study, participants who were switched from semaglutide to a placebo experienced a nearly 7% weight rebound in just 11 months. But the consequences extend beyond the numbers on the scale. The metabolic improvements achieved through these drugs, such as lower blood pressure and cholesterol levels, also tend to revert to pre-treatment levels once the medication is stopped. The excess weight, particularly around the midsection, can also lead to the resurgence of health risks like fatty liver disease and insulin resistance. Obesity experts emphasize the need for a comprehensive approach to weight management, one that goes beyond just the medication. Maintaining a healthy lifestyle through diet, exercise, and mental health support is crucial, even after reaching the desired weight. However, for some individuals, the temptation to return to old habits can be irresistible, leading to the dreaded weight rebound. As the obesity epidemic continues to grow, with the World Health Organization estimating over 1 billion affected individuals globally, the quest to find sustainable solutions remains a pressing challenge. Researchers and clinicians are now advocating for a deeper understanding of the long-term implications of these weight loss drugs, as well as the development of more comprehensive care models that can support individuals both during and after their treatment. The story of obesity medications is a complex one, with triumphs and setbacks, successes and frustrations. But as the scientific community continues to unravel the intricacies of this issue, the hope remains that a more personalized and enduring approach to managing obesity can be achieved, empowering individuals to maintain their health and well-being for the long haul. Source: www.nature.com. Unlocking the Human Proteome, Advancements in Brain, CSF, and Plasma with TOPMed Imputed Genomics. Uncovering the Genetic Secrets of the Human Proteome, a groundbreaking genomic study. In the ever-evolving quest to unravel the complexities of the human body, a team of renowned scientists has made a remarkable stride, shedding light on the genetic underpinnings of protein regulation across multiple tissues. This comprehensive study, leveraging the power of the TOPMed imputed genomics, has significantly enhanced our understanding of the genetic control of the human proteome in brain, cerebrospinal fluid, CSF, and plasma. The researchers, building upon the previous work, have now analyzed a staggering 1,300 proteins in brain, 869 proteins in CSF, and 953 proteins in plasma, a substantial increase from their earlier study. By harnessing the improved TOPMed reference panel, they were able to impute a remarkable 8.4 million high-quality genetic variants, nearly doubling the number of variants examined in their previous investigation. The findings are truly remarkable. In brain, the team identified 38 genomic regions associated with 43 proteins, including 12 newly discovered loci. In CSF, they uncovered an astounding 150 genomic regions linked to 247 proteins, with 30 brand new loci. And in plasma, they revealed 95 regions associated with 145 proteins, 22 of which were previously unidentified. But the story doesn't end there. The researchers delved deeper, meticulously disentangling the independent signals within each locus, unveiling the intricate genetic architecture underlying protein regulation. In CSF alone, they found an astonishing 47 loci with more than one independent signal, showcasing the remarkable complexity of the human proteome. Intriguingly, the team also identified numerous pleiotropic loci, genetic regions associated with multiple proteins, underscoring the intricate web of genetic regulation. The APOE locus on chromosome 19, for instance, was linked to an impressive 15 proteins in CSF, while the major histocompatibility complex, MHC, locus on chromosome 6 was associated with 16 proteins in plasma. As a testament to the study's clinical significance, the researchers delved into the potential causal relationship between the identified proteins and Alzheimer's disease, AD. Employing Mendelian randomization and Bayesian colocalization analyses, they uncovered evidence of causality for several proteins, including the intriguing case of cathepsin H. This protease, found to be causally linked to AD risk in all three tissues, serves as a prime example of how this groundbreaking work can uncover critical molecular pathways underlying complex neurological disorders. To ensure the broader scientific community can benefit from these invaluable insights, the researchers have meticulously curated their findings and made them accessible through the online Neurodegenerative Trait Integrative Multiomics Explorer, OnTime, web portal. This interactive platform allows researchers to explore the intricate relationships between genetic variants, protein levels, and disease associations, paving the way for future breakthroughs in the field of neuroscience and beyond. In the ever-evolving world of genomics and proteomics, this study stands as a beacon of hope, showcasing the power of integrative multi-omics approaches to unravel the intricate mysteries of the human body. By harnessing the latest advancements in imputation and bioinformatics, the research team has delivered a groundbreaking resource that promises to revolutionize our understanding of the genetic control of the human proteome, ultimately paving the way for novel therapeutic strategies and personalized healthcare solutions. Source: www.nature.com